Right, we're still working on two unknowns, and let's look at some of the other programs that we haven't done that will draw out some concepts for Algebra 1 and Algebra 2. Let's look at an inverse. Now, we talk about functions as having inverses. And there are different kinds of functions. We can just have a single point. Well, we could have, kind of boring, but could be. We can have a discrete function, which means it's not connected. And then you can have a linear function. We can have mixed problems here. So we're going to start with the easiest one, and we're going to see how we go about making the inverse when we have a point, when we have lots of points, when we have a line. And I have here a clue as to how to go about doing this. This is a picture of I think this was in Philadelphia at a hotel I stayed at a math conference, and I thought it was a very interesting thing, and it looked like a big, huge point, so I thought it would make a good graphic. Maybe someday you'll see it. I'm going to do a point problem. Now we want to click on the inverse of the red point. Now this red point is the point 1, 2, 2, 1, 2, 3, 4, 5, 6, 7, 2, negative 7. If you didn't want to count, look, I did it for you. Now we want to click on the inverse of this point. So say you didn't remember. Here's the clue. To find an inverse, switch the x and y. Oh my goodness, that's really complicated. So switch the x and y. The inverse of this point is the point negative 7, 2. 1, 2, 3, 4, 5, 6, 7, 1, 2. There it is. There's the inverse of that. Now, you see over here to the right that I put this button that says line y equals x, because we might dilly-dally around and hold off on telling you, but we've got this visual representation here. If I put in the line y equals x, you will see that the inverse of this red point is the reflection of this blue point in this line, like it's the same distance from this blue point to the line as it is to the red point in the line, and they are along the perpendicular between them. Oh, let's look at that clue again. To find an inverse, switch the x's and y's. Let's do one other point. This is the point negative 3, 0. So the inverse would be 0, negative 3. 0, negative 3. And I'll put the line y equals x. You can see that these are reflections in that line. Easy, huh? Got it? Let's go on to a discrete function. Discrete means that just particular ones. So look, there's a discrete function, and there are all its points. I could go and go. The inverse of the point negative 2, negative 1 would be negative 1, negative 2, negative 1, negative 2. The reverse of this would be negative 2, negative 1, negative 2, negative 1. Oops, I missed it. Negative 2, negative 2, negative 1. What was I thinking? The inverse of this point would be 2, 0, 1, 2, 0. This would be 1, 1. This would be negative 3, 2. 1, 2, 3, 1, 2. This would be 0, 3. 1, 2, 3. This would be 3, 4. 1, 1. And then I put in the line that says, excuse me, I'm sorry about coughing there. I put in the line y equals x for you, and you can see that the blue and red points are all symmetrical across this. This program would be a lot more interesting if instead of just, doing these points mechanically by, what's the clue? To find the inverse of a discrete function, switch the x's and y's. You could have a little bit of fun with this to see if you've got the visualization of the perpendicular and the reflecting through the line y equals x. By doing this, I like to sort of do this myself. The reflection of this point would be that point itself. It's its own inverse. What about this point? Looks like it's right across from there. What about this point? Looks like it's right across from there. What about this one? Looks like it's right across from there. What about this point on the line? It's its own reflection. That one's there. Let's see, did we miss anybody? I had, this point is 1, 2, 1, 2. Oh, look, I didn't even look at any of the points, but I could see the inverse because they are across this divide. Anybody see that? Almost. Fun. Now, let's look at a linear function. This time, we want to have this in the inverse of the line y equals x plus 4. And that would be impossible to go clicking every single point along here because there's an infinite number of points here. So in order to express this inverse, I'm going to have to write an equation. So I'm going to bring up the marker here. Oh, and maybe I need to minimize it before we need to look at the clue first. Let's look at the clue for this. To find an inverse, switch the x and y's. Oh, look, I have a little thingamajigger over here. I forgot I gave that. So I guess we didn't need the marker. Here's the equation we're trying to find the inverse. Y equals, now pay attention to this because I don't want to work a whole bunch of these. Y equals x plus 4. To find the inverse, what we do is we switch the x and y's. So that would be x equals y plus 4. But to write this equation down, I have to put in point-slope formula. So that means I need to solve for this y, which would mean I'd subtract 4 from both sides. So it looks like it's y equals x minus 4. 1x minus 4. Check, we win. See the inverse. It's the reflection of the red line in the line y equals x. You probably could have figured that out from sight. Let's do another linear function. Here's the equation. Y equals minus 3x plus 1. And to find the inverse, switch the x and y's. So the inverse would be x is equal to minus 3y plus 1, or minus 3y equals x. I hope this doesn't confuse you here. I'm going to subtract 1 from both sides and then turn the whole thing around. And y equals negative 1/3 x plus 1/3. So this looks like it's negative 1 divided by 3 and 1/3. And I'm about to check. Now, before I push OK and we see the line, let's think, what would its reflection look like in that line y equals x? There it is. Look at the line y equals x. The blue and red lines are reflections of each other in that line y equals x. So whenever anybody asks you to find the inverse of a point or a discrete function or a linear function, the clues are always the same. I didn't have to write a different clue for each type because the answer is always to find an inverse, switch the x and y. If you're doing a linear function, then you want to put it in point-slope form. Keep your eyes open. There's something special that I didn't learn about until the last 10 years because I didn't keep my eyes open. There's something special about those lines, about the slope of those lines of a linear function and its inverse. Watch out. See if you can tell about its slope. There's a theorem in calculus that this will help you to understand. So pay attention to what those lines look like. I never did. I just found the inverse and was happy that I could find the inverse, but I wasn't watching for patterns. Keep your eyes open. Have fun.